Okay, I'm just doing Route 53 stuff. Don't mind me. Do a little bit of stream setup here for syncing. Okay, stream settings, enable auto stop. That's like the worst setting ever. Freaking auto stop's so dumb. Yeah, so what? Sometimes my thing goes missing.
On the Route 53
Okay, so what is this?
service. Okay, so let's open the route.
I need to.
So now that we know what, so the public hosted zone and the private hosted zone work the exact same way, but just the public hosted zone allows anyone from the internet to query your records. So this is for your public records, whereas the private hosted zone is only queried from within your private resource public way, but just the public hosted the database. So the public hosted zone and the private hosted zone work work the exact same way, but just the public hosted zone allows anyone from the internet to
How's anyone from the internet
query your records.
to query your DNS records
So this is for your public records, whereas the private hosted zone
while the private
is only
zone is
queried
only query
from within your private
from within
resources, for example.
your pri from within your private resources.
Your VPC.
For example, your. All right, so private. Okay, so yeah, so I gotcha. Okay.
Okay, so that's it for.
Yeah. Okay. Let me draw this. I like drawing these diagrams. They're fun. And the cool thing about these diagrams, they look really cool on paper. It's like artwork. Alright, so we got the private hosted zone. Private hosted zone. Let's underline this boopy. Private hosted zone. What we got here? We also have, what are the other players? We have the instance, EC2 instance. Okay, so we have EC2 instance. API dot, so it's EC2 instance. I am going to make this a little big. It's like, then we have another EC2 instance. EC2. Then we have a DB instance, database instance, which is like, I need to make it smaller too. Now here we have DB, like an RDS or an Aurora instance. This DB, for example, it's like DB dot example. This is like API dot example.com, and this is web app. Oh, this is so perfect. Full stack web development. Web app dot example. Oh, this is API dot example dot internal. Okay, I made a mistake. Sure. API dot example dot. Wait, what? It's not .com, it's .internal. Okay, web dot example. So the root is like of the root of a VP of a private hosted zone. Wait, no. So that's like a. I'm kind of confused about this. I get it now. So this is the first arrow. The first arrow is we have a web app, internal web app that we have access for. And this internal web app, it goes like, yo, private hosted zone. Can you give me API dot example dot internal? Because dot internal is just like, what is that? What is .com? .com is your, there's a root. .com is a secondary. So this is like a secondary internal, yeah, second level domain, internal second level domain, dot internal. And then, yeah, API example.com. And you want the API to access the database. Yeah, so this is the internal computer of that. So once you get this, we move on to here. And then this thing goes, yo, what is the DB IP? DB dot example dot int. And then this thing returns back with a DB example int IP, which is a D0035. Yeah. Now once we have the database IP, we can proceed on to get the database instance data that the internal web app wants. And we can put this all under, nah, it's fine. It's pretty explanatory.
For the theory, now let's go into the next lecture to register a domain and then create some records. So I will see you in the next lecture.
Register some domains and create some records.
Let's open the root 53.
Alright, let's do it. It's peanut butter demo time. Peanut butter demo time. Root 53. Okay.
3 service, which is a scalable DNS management system. Okay.
Scalable DNS management system.
So as we can see, there's only one hosted zone for me and one domain for me. That's because I've already registered a domain, but for you, it should say 0 hosted zones and 0 domains. So let's go on the left-hand side into register domains. And as you can see here, I've already registered a domain called stefan.teacher.com. So, and as you can see here, I've already registered a domain called stefan.teacher.com. So this is something I've purchased in the past and something that's...
Well, let's go to my other account because I have some domains. And there's setting the root email. I need to go. I am root. Let's go to, I believe. Okay, hold on a second. Which account has the most stuff? Let's check the main one. CW26T5. Alright guys, let me do something real quick. I need to figure this out. Where's my phone? Gotta check my passwords. Yes, okay, I'm being dumb. Sign in. 2F T. Scan. 5 4 8. Yes. What the frig? My passwords are right. I need to reset my password. This is gonna. Damn, what the fuck? Okay, so. Okay, so. B6 M4 B7. Alrighty, so I fixed my account.
If you
Go Route 53. Register
want
domains.
to follow this
See my domains. Pokédex.com, baby.
uh,
It's gonna be the sickest company ever.
this section with me, you will have to purchase your own domain. So it has to be a domain that doesn't exist already. Okay. So I've purchased stefanitri.com, but let me register a domain with you. I will not go all the way with
Wait,
the domain purchase, but
do I have like a bunch of domains? Let me double check which ones I have. I think I have like Lieutenant Surge, LT Surge. Which one is that on? Oh, this is Surge.link. Okay, so. Oh, sick. I have Lieutenant Surge. Yeah, that's the one. I can't believe I have LieutenantSurge.com. That's so cool. Okay, so which account is that? That is. AWS Surge 2012. Okay, let's try it out. So it's sign out. Log back in. 25XDTM. Done. Route 53. Register domains. Boom. To Surge. Does this one do anything? LTSurge.com. Yeah. Oh, GitHub. Hmm. That's weird. Does that mean that GitHub slash LT Surge repositories? Yeah, so one sec. Oh, so yeah, this is what I need to. I need to work on this one. This is perfect. I need time to. I need to check this. Okay, so we have.
But I can show you at least the steps. With this section with me, you will have to purchase your own domain. So it has to be a domain that doesn't exist already, okay? So I've purchased stefanitio.com, but let me register a domain with you. I will not go all the way with the domain purchase, but I can show you at least the steps. So first, we need to choose a domain. For example, no one has this domain except stefan.com. I'm pretty sure this is going to be available. Let's check. And yes, it is available. So here we see the domains and the price. So this is something that's going to cost me $12 per year, okay? So just so you know, if you go ahead with this, well, you can practice alongside with me, but it will cost you a little bit of money. If you want to remain within the free tier of AWS, you cannot go ahead with this section. You just have to watch. Okay, so let's add this to cart, and we're going to register this domain for 1 year. You cannot do anything lower than that. Let's click on next, and then you have to specify the contacts for your domain. So you can say the contacts that you have. So I will let you fill that in. And if you have the option, please enable privacy protection. This is to make sure that your contact details are hidden for .com domains, and therefore you're not going to be spammed by some people after you register a domain. Next, you check your contact details, which should look good. And then automatically, we will be using route 53 to manage your domain. Do you want to automatically renew it? Yes or no, it's up to you if you want to keep it forever. And then, do you accept the terms and conditions? The answer should be yes, and then you can complete your order. So once this is done, you're going to have the domain being registered. It can take maybe a few minutes, maybe a few hours, but then you should be good to go and the domain should be ready. And finally, from there, you can go into your hosted zones And you should see a new hosted zone for your domain name that you just purchased. And as you can see, the type will be public. It's created by Route 53 directly. You should have 2 record counts. And then in this hosted zone, if you click on it, you're going to have the NS records and the SOA records. So to make it simple, the only one you should worry about is this
And these right here, I get it now. This A record I put pointing to others. I bet this is going to take to GitHub. Yeah, see? This is exactly what's going on right here. Because I don't have a CNAME record here anymore. I freaking get it now. So sick. So the reason why when I go to ltsurge.com, it gives me this. It's because it's literally doing this. It's pointing. It's going to the. It's going to the secondary level domain name system called Route 53. And Route 53 is giving them this. And I'm supposed to go here and add a CNAME record. Beautiful. If I wanted to make this, for example, Surge, LT Surge.
one, are not worried about, but just look at. So the
See, I want to clear this.
NS tells you the name
Let's have it here.
servers. It's saying that, okay, for this domain name, stephaneteacher.com, worry about the NS records and the SOA records. So to make it simple, the only one you should worry about is this one, or not worry about, but just look at. So the NS tells you the name servers. It's saying that, okay, for this domain name, stephaneteacher.com, then these servers are the authoritative answers. They can give you the values of whatever records we're going to have in this table, okay? So that's it for registering a domain name. I hope you liked it, and I will see you in the next lecture to start creating some records. So now let's go ahead and create our first records in Route 53. So I'm going to go into my hosted zone, and in there I'm going
We can delete this.
to create some simple records. So let's have a look. We're going to create a record by clicking on here. And in here, I can just have a record name. So we want it to be test.stephaneteacher.com. You can enter anything you want here. This is how you would create your domain names. Now you have to specify the record type. So as you can see, there's a
Domain names.
lot of record types in here, but for now we'll keep it simple. We'll keep it as an A record, and which is to route an IPv4 address into a domain name to an IPv4 address. So the answer is going to be value is 11.22.33.44. Which is just a value we want to have, and this is not a domain an IP we own right now, but just to show you just a random value. Later on, we'll be routing to a real EC2 instance. Okay, TTL is time to live. We'll leave it as 300 seconds right now. And the routing policy, we'll have a look at it later on as well. We'll leave everything as simple routing. Okay, so let's go ahead and create this record. And now my record has been successfully created. So the idea is that if I go to test.stephantheteacher.com, it is going to ask my hosted zone what is the value of that, and the hosted zone is going to say, well, the value of it is 11.22.33.44. So if you try to do it with a web browser, so if you take your web browser and you open it and you press enter, it's not going to show you many things because right now we don't have 11.22.53.44. There's probably no server that exists with that IP as well. And if I try to just access this URL, it doesn't work. Okay. So what we need to know is what is going on behind the scenes. And so for this, we're going to type some command lines. Now you can be using your command line on your Windows laptop or your Mac, but because I want everyone to follow the same way as me, I'm going to show you how to do it using the Cloud Shell environment in AWS. So let me open the management console, and then I'm going to click here to open Cloud Shell.
Wait, hold on a second. What are you doing? Where's the management console?
As me, I'm going to show you how to do it using the Cloud Shell environment in AWS. So let me open the management console, and then I'm going to click here to open Cloud Shell. And I'm going to show you how to do it using the Cloud Shell environment in AWS. So let me open the management console, and then I'm going to click here to open Cloud Shell. And Cloud Shell is going to allow me to do some commands using a standard Linux command line interface, okay? But this is fine if you want to just do it with your own terminal on Windows or on Mac. Okay, so my terminal is now ready. And if you're on Windows, the ns lookup command is going to work. If you're on Mac, the dig command is going to work as well. But as you can see, these commands are not found on my Cloud Shell. So I need to install them. So I do sudo yum and then install -y and then bind -utils. And this is going to install both the ns lookup and the dig command on my.
Wait. Okay, so I like these commands. We got sudo yum install -y find util. Okay.
Install both the ns lookup and the dig command on my Cloud Shell. So let's clear the screen. And now let's try to do ns lookup test.stephantheteacher.com. And as you can see,
ns lookup test.surge ltsurge.com. Alright, so we got here.
I get an answer, which is at
Ooh, it's got my 11223334. Nice. So that's kind of cool. This is find utils. I love learning these like little freaking tidbits. These little commands. Okay, so that's next example. If we do ns look up test dot surge .com or ltsurge.com, we get
test.stephantheteacher.com is.
let me see. address 27.0.0.1 number 53 non authoritative answer. It says name test.ltsurge.com, and because we have a record for it, it actually gives us address. Address 112233.44. What we have in record.
Going to 11.22.33.44, which is corresponding to what is happening right here, which is cool. And I personally like the dig command a little bit more.
Okay, and this is corresponding what is happening over here. Pretty nice.
More because I'm more familiar
He likes the dig command. It's even better than this ns lookup
with it. But if you type dig and then the URL that you have.
Okay, let's try this. Dig test.ltsurge.com. Whoa, what do we got here?
Okay. And press enter. You're going to
Got answer. Header.
see that and have the wrong command. So stephantheteacher.com. So let's clear the screen and then retype the command. Okay. What here we're going to see is that we have the answer section and it says test.stephantheteacher.com is an A record, and this is the value of.
Oh, okay, cool. I actually like that a lot more too. Okay, even better. So, but wait, there's more. Even better. Even better command. Yeah, these commands are dope, dude. NS lookup. And then we can do even better command, which is gonna be dig. What does we do? What do we do? Dig test. Yeah. Dig. Dig matter. This. Dig test. Dot. LT.com. Interesting, because we named this record test ltsurge.com, and we do this dig command, and then it's going to return us answer section. Okay, that's really cool. 111 in a record. Okay, so let's just do. And then we have whatever 111 means, but the most important part says in a record, and then it says the value 1122.3.44.
Of the record. So I like it better because it shows you the TTL, as we'll see later on.
Oh, it actually gives you. Oh, that's a TTL. Oh wow. Okay, so this is a. Okay, so this is TTL. Time to live. Yeah, it's got. All right. So if you do it again, it's gonna be like what? Less? Like 300? Like let's see, like 307. Is it? Okay, whatever.
And also shows you the A record, the fact that it's an A record. Okay.
Type And this is the value.
So we have created our first root 53 record, and we have been able to query it using a terminal, which is cool.
Okay, so we created our first
Root 53
route 3 record,
record, and we have been able to query it using
and we created
a terminal, which is cool.
it using a ter. No, yeah, it's
Obviously, loading it from a web page doesn't work right now, but we'll see how we can.
loading from web page doesn't work right now.
Do it later on when we have a real server.
We learn to later. And,
So I hope you like this lecture, and I will see you in the next lecture.
let's go.
So let's get started and be.
Okay. Alright, so now that I can switch back. Nice.
Before we use root 53, I want to go ahead and create 3 EC2 instances. Let's get started, and before we use root 53, I want to go ahead and create 3 EC2 instances in different regions as
Is this another hands-on?
well as one ALB. So in one of these regions, I'm going to go in. So let's get started, and before we use root 53, I want to go ahead and create 3 EC2 instances in different regions as well as one ALB.
Wait, it was LB auto load. Oh, it's application load balancer. Okay, so he wants to create 3 EC2s in application load balancer. Okay, let's go.
So in one of these regions, I'm going to go into instances and then launch an instance. And very simply, I will choose Amazon Linux 2 on.
Wait, I should do this too, I think, right? I feel like I should do this too. Good practice. First, let me eat a chocolate bar. Big, got some Trader Joe's. Trader Joe's dark chocolate, 72%. He finally brought it back. The Belgian stuff is where it's good.
This architecture, a T2 micro.
Okay, let's actually do this phone.
So let's get started. And before we use root 53, I want to go ahead and create 3 EC2 instances in different regions as well as one ALB. So in one of these regions, I'm going to go into instances and then launch an instance. And very simply, I will choose Amazon Linux.
I like Ohio better, dude. Ohio would say it.
2 on this architecture, a T2 micro type of instance. I don't need a key pair because I will use, if I need to, I will use EC2 Instance Connect. And then For network settings, I'm going to create a security group. I will allow SSH as well as HTTP from anywhere. Then I will just, in advanced details, specify a bootstrap user data script. So to do so, just go into your root 53 user data.sh script, and you copy this entire script and you paste it here. So what it's going to do is it's going to say hello world from the instance just as before, but now we're going to add the AZ the instance was launched in using this environment variable called EC2 availability zone that I created from before. So it's going to give us a little bit more info about each EC2 instance. So I'm going to go ahead and launch this instance.
Wait.
So this has been launched and it is right here. Okay, that's good. Next, I'm going to go into another region, for example, Northern Virginia, so US East 1, and then I will
Hold on a second. Wait, no. I want to go to North Virginia too. Wait, what? Oh yeah, huh? This is my instance, okay? Oops.
launch an instance and same settings. So again, no key pair required. So proceed without a key pair. I will allow HTTP as well. And for advanced details, I will provide the exact same EC2 user data script. Then we click on launch instance and we're good to go. And finally, I'm going to go into one last region, for example, Singapore. And in Singapore, I'm going to launch an instance. And then we'll leave it as T2 macro. We will choose no key pair. We'll allow HTTP from anywhere. And then under advanced details, I'm going to paste in the data and launch this instance. Okay, so we have 3 instances now being started in 3 different regions. So we have one in Frankfurt, one in Northern Virginia, and one in Singapore. So this is good. Lastly, what I'm going to do is that I'm going to launch a load balancer in Frankfurt, for example.
Go to Ohio. I like Ohio. Ohio. So they want.
So here I'm going to create a load.
No.
A load balancer. Then under advanced details, so we have one in Frankfurt, one in Northern Virginia, and one in Singapore. So this is good. Lastly, what I'm going to do is that I'm going to launch a load balancer in Frankfurt, for example. So here I'm going to create a load balancer and choose an application load balancer, create, and then the unique name will be demo root 53 ALB. This is fine. is going to be internet facing on IPv4. I will choose for mapping 1, 2, and then 3 subnets. And for security group, I can choose up to 5. So I'm going to choose the one that I've created just from before, which was the launch wizard 2, which had SSH and HTTP enabled. This way, we're sure that HTTP is enabled. And the protocol is on 80. You're going to forward to a new target group that we're going to have to create based on instances.
We just had.
And I'll call it this one demo tg root 53. And what I want to do is root.
Oh yeah, demo target group route 53.
53. And what I want to do is next and register my one instance right now that I just created from before. So you do include as pending below. Then on the review targets, you have one target and then create.
Right.
Below. Then on the review targets, you have one target and then create the target group. So the target group is not created. So back into my load balancers, I can refresh this and select the demo TG group root 53. And everything looks good. Let's create our load balancer. And then click on view load balancer. And here we go. So now to summarize, let's see if everything has been working properly. So here we go. So now to summarize, let's see if everything has been working properly. So we have one EC2 instance right here. And let's take the public IP. So I'll just copy the IP itself. Make sure two instance right here. And let's take the public IP. So I'll just copy the IP itself. Make sure using the IP via HTTP. And it says hello world from blah, blah, blah. So this is good. So what I'm going to do is that I'm going to, under a text file, just to have a mark of a trace of everything, I'm going to put the IP address as well as the region I'm in. So EU Central 1. As you can see, it says hello from AZ EU Central 1B. So of everything, I'm going to put the IP address as well as the region I'm in. So EU Central 1. As you can see, it says hello from AZ EU Central 1B. Okay, so this instance is working. I'm just testing whereas everything is working. So I'm going to also take this public IP right here. paste it in, and it says yes, hello from US East 1A. So this is perfect. So this is US East.
Wait, what's going on? Yeah, it makes sense. So that was US, yeah.
It's 1. And the last instance right now, it's here. And then I'm going to copy this IPv4 address, paste it in, and it says hello from AP Southeast 1B. So this was working as well. So let's go here, AP Southeast 1. And finally, if I go under my ALB and take the DNS name right here, let's see if it has been provisioned. So let's refresh this. So if I take the DNS name right here, let's see if it has been provisioned. So let's refresh this.
So I should go to this one, yeah. Let's do it.
So it is provisioned, as we can tell. So this can take a bit of time. So for you, it may not work. For me, it worked. And so because it is pointing to 1:2 instance, it's a hello well from AZ EU Central 1B. So now we have properly set up all our instances as well our DNS. So we're good to go. And keep this information handy.
Shoot.
And I will see you in the next lecture.
Let's go.
Okay, so let's have a look at TTLs.
Let's have a look at TTLs. Man, there's so much to go still. Holy crap. Man, all this stuff is so important to know. Jesus. Industry knowledge. Is my stream still gone? Oh, am I freaking streaming? Nice, dude. Everything's working.
So a record TTL is a time to live.
Record TTL is a time to leave. What? Yeah, I know that record. What the hell is time to live though? Like, what the freak? Why do they need that? Why do they need to have a TTL? Why do records need?
And let's take this example where a client is accessing our DNS route 53 and a web server. So we do a DNS request for myapp.example.com, and we get an answer from the DNS, which is saying, hey, please, this is an A record, here is the IP, and there's a TTL, maybe a TTL. My app client is accessing our DNS route 53 and a web server. So we do a DNS request for myapp.example.com, and we get an answer from the DNS, which is saying, hey, please, this is an A record, here is the IP, and there's a TTL, maybe a TTL of 300 seconds. So TTL is saying, hey, client, please cache this result for the duration of the TTL. So for 300 seconds, the client is going to cache the result. That means that if the client is requesting again or accessing the same host name, what's going to happen is that the client will not issue a query to the DNS system because it already knows the answer, because the answer has been cached and we're still within the cache period. So the cache TTL.
So the TTL is for the client to cache. The Route 53 doesn't do shit. So the client caches a TTL, and then next time you go back, you don't you. What? Oh.
The idea behind this is that we don't want to query the DNS too often because we don't expect records to change a lot. And so therefore, using the response it has, the client can access our web server and do HTTP requests and responses. So we have two extreme cases. For example, if you set a high TTL of say 24 hours, then this is going to do a lot less traffic on Route 53 because less clients are doing requests because the results are cached for 24 hours. And possibly, well, the client will have outdated records. If somehow you want to change the record, you will need to wait 24 hours to make sure that all your clients will have the new records in their cache. If you set a low TTL, for example, 60 seconds at the opposite, then it's going to do a lot more traffic on your DNS. So a lot more dollar you're going to spend because you get price per how many requests do reach Route 53. But the records will be outdated for less time, so it's quicker for you to do a record change. And it's easier to change records overall. So it's up to you really to see what a good TTL or OTTL is. If you plan on changing a record, the idea is that sometimes you will decrease the TTL for say 24 hours. And then when you know that all the clients have a new TTL that is low, then you change the record value, which gets updated for everyone, and then you increase the TTL. This is a strategy. So the TTL is mandatory for every record except the alias record that we'll see in the next lecture. So let's have a look how TTL works in the console. Let's take this example where a client is accessing our DNS route 53 and a web server. So we do a DNS request for myapp.example.com, and we get an answer from the DNS, which is saying, hey, please, this is an A record, here is the IP, and there's a TTL, maybe a TTL of 300 seconds. So TTL is saying, hey, client, please cache this.
Okay. request to Amazon, make a DNS request, and Amazon returns you your request and gives you an A record. It checks the A record for that name and gives you 12, 34, 56.78 with a TTL. This is huge. With TTL, which is like a cookie or something.
This result for the duration of the TTL. So for 300 seconds, the client cache of .com, and we get an answer from the DNS, which is saying, hey, please, this is an A record.
Hey client, this is an A record, my app.example.com, which points to this IP.
Here is the IP, and there's a TTL, maybe a
And there is a
TTL of 300 seconds.
of 300.
So TTL is saying, hey, client, please cache this result.
TTL. Hey client, please cache
For the
this result
duration of the TTL. So for
for duration of
300 seconds, the client is going to cache the result. That means that if the client is requesting again or accessing the same host name, what's going to happen is that the client will not issue a query to the DNS host name. What's going to happen is that the client will not issue a query to the DNS system because it already knows and so therefore using the response it has, the client can access a web server and do HTTP requests.
That's essentially exactly how I do it, but I do a slightly more fancier way with an Angular service. Yes, you're right.
requests and responses. So we have two extreme cases. For example, if you set a high TTL of
Dude, this is amazing.
say 24 hours, then this is going to do a lot less traffic on Route 53 because less clients are doing requests because the results are a lot less traffic on Route 53 because less clients are doing requests because the results are cached for 24 hours, and possibly the client will have outdated records.
Who cares? Outdated records for what, like a day?
If somehow you want to change the record, you will need to wait 24 hours to make sure that all your clients will have the new records. In their cache. If you set a low TTL to make sure that all your clients will have the new record, you want to change the record, you will need to wait 24 hours to make sure that all your clients will have the new records.
So I changed the record. If I change the record, the client's gonna go to oh client client will be redirected to old broken yeah. Be okay. So high TTL is a little bit Tricky.
in their cache. If you set a low TTL, for example, 60 seconds at the opposite, then it's going to do a lot more traffic on your DNS, so a lot more dollar you're going to spend because you get price per how many requests do reach route 53. But the records will be outdated for less time, so it's quicker for you to do a record change, and it's easier to change records overall. So it's up to you really to see what a good TTL or OTTL is. If you plan on changing a record, the idea is that sometimes you will decrease the TTL for, say, 24 hours, and then when you know that all the clients have a new TTL that is low, then you change the record value, which gets updated for
That's pretty cool. I get it now. So what happens is, if you want to change, so the TTL thing is, you have a client. He requests to your Amazon 53, saying, "Hey, give me example.com." Route 53 is going to return you, because that's the route A record that belongs there, an A record with that IP address, so you can go to your example.com. But it's also going to give you the you a TTL, a time to live cookie, and that time to live cookie is usually high because you don't want to hit the Route 53 a lot. And then when you go to your web server, but then when you but if you want trying to maintain and change the Route 53 record without hurting your client's experience, what you do is you first go to the TTL for the record and change the TTL to something small. And so the next time when the TTL expires in 24 hours, your clients get are gonna get the small TTL, and and so and you could switch with a small routine. You could switch quickly, and they will have and then you can just switch like that. So yeah, perfect. I get it.
everyone, and then you increase the TTL. This is a strategy. So the TTL is mandatory for every record except the alias record that we'll see. see in the next lecture. So let's have a look how TTL works in the console. So let's have a look at how time to live works. So let's create a new record.
Let's see how time to live works. Okay, so.
And this. So let's have a look at how.
Okay. So. Let's have a look.
How time to live works. So let's create a new record. And this one is going to be called demo.stefanoteacher.com. And the value of it is going to be one of the EC2 instances we know. So let's take the one in.
Oh, cool. So this is why we. Wait, this is where do you have that? Let's do another one, second one. Wait. One, seven, two. Private. Nah. Yeah, it's fine. No, I don't do it. Okay, I want the second one. Yeah.
New central one. So I'm going to take this EC2 instance.
Okay. We'll just be sure. So. This is Oregon. Virginia is actually 2. Yeah, it's perfect. I want the Virginia one, 54. And that's what I got. Perfect. Sanity checks. And we want to make a demo with this. Okay.
And paste the value of it. And then for the TTL, we're going to set 2 minutes. So to do so, I'm going to click twice on this minute button. So the TTL is now 120 seconds. So let me create this record. And now my record has been created. So it is an A record.
That's so cool. I love these sub demo stuff.
Pointing to a specific IP at demo.stefanoteacher.com.
So you tell me if I go like this, I'm gonna do. Is it gonna give me that? No way. No, bro. Sick. No way, dude. Sick.
Now I want to show you that the record is working, but Firefox is not very nice with me. So if I try to open this in Firefox, it's going to give me a problem. So this is not something I can fix easily. So I'm going to use Google Chrome on the right-hand side to show you this. So if I do demo.stefanoteacher.com on Google, then automatically it should direct me to, yes, my EU Central Wall instance. So that means that this record, this
so cool, dude. That means that this record demo is pointing to my second EC2, which is right here, 54. And then go demo. So no.
A record is fully functioning. And I can also make sure of that. For example, if I'm using Cloud Shell, so if I clear.
Yeah, let's do this. I like Cloud Shell. Where's my Cloud Shell? Cloud Shell. Get out of here.
Clear this and do an NS lookup on demo.stefanoteacher.com. As you can see, the address is correct. And if I do a dig command on this, then we get an answer.
So I have to do the other thing. I have to do the command install. So sudo yum. Oh, why isn't it working again? I thought I had Ohio. I guess you have to do it. Sudo yum and install. Okay, now I got that. Yes. And demo, yeah, address. Yeah, and dig.
And there's a cool number that was shown here. So the intersection, that is 115. So the idea here that because I did do a DNS query, then the record got cached for 120 seconds. And if I retype again this dig command right here, as you can see, the number got down to 98. So that means that for 98 seconds, actually, I will get the same response because no matter what, this is what's cached on my computer. So if I'm very quick and I go to this record right here and I edit it, so instead of this this IP, I want to go to AP Southeast 1. So I will use the first IP in my list and save this. So even though this record was being updated, okay, if I go into Cloud Shell and again do this dig command, as you can see, the answer is still the same as before. That's because for 66 more seconds, this is going to be cached. And if I go to Chrome, I think I was fast enough. I go to Chrome and refresh this page. As you can see, I still have the answer from EU Central 1. This is because, again, my record got cached for 2 minutes. So when the cache is expiring, then only then my command line interface or my Chrome web browser will ask again root 53 for the value of this record. And then again, will I get the answer and will be redirected to this new IP. So the best way to check it is just to wait. So I'm going to wait maybe 1 more minute and then get back to you. Okay, so it's been a minute. And now if I refresh my web browser, as you can see now, I get a different hello world. And this time is from AP Southeast 1B. And if I go into my Cloud Shell and do the same dig command, then as you can see, there's a new TTL, so 120 seconds, and there is a new IP right here, which is the IP of my new server. So this was a cool demo of the TTL. I hope you liked it, and I will see you in the next lecture.
Yeah, it's pretty cool.
So now let's have a look at the differences between CNAME.
So now let's have a look at the difference between CNAME and alias. Yeah, dude. Let's go. Let's have a look.
And aliases. So when you have an AWS resource, for example, a load balancer or CloudFront, it will expose a host name. And what you want is to maybe map that host name to a domain you own. For example, you want to map this load balancer into myapp.mydomain.com. So you have two options. The first one is to use a CNAME record. So we've seen A records, but now let's look at CNAME records. So CNAME allows you to point a host name to any. So now let's have a look at the differences between CNAME and aliases. So when you have an AWS resource, for example, a load balancer or CloudFront, it will expose a host name. And what you want is to maybe map that host name to a domain you own. For example, you want to map this load balancer into myapp.mydomain.com. So you have two options. The first one is to use a CNAME record. So we've seen A records, but now let's look at CNAME records. So CNAME allows you to point a host name to any other host name. For example, you can say app.mydomain.com is pointing to blah blah.anything.com. And this only works if you have a non-root domain name. So if you have something.mydomain.com, it does not work for just mydomain.com, as we'll see in the hands-on. Something.mydomain CNAME records. So we've seen A records, but now let's look at CNAME records. So CNAME allows you to point a host name to any other host name. For example, you can say app.mydomain.com is pointing to blah blah.anything.com. And this only works if you have a non-root domain name. So if you have something.mydomain.com, it does not work for just mydomain.com, as we'll see in the hands-on. On the other hand, you have alias records, and these are specific to Route 53, but they allow you to point a host name to a specific AWS resource. So app.mydomain.com is pointing to blah blah.amazonaws.com. And these resources we'll see in a second what they are. But these alias records work for both root domains and non-root domains. So you can have mydomain.com pointing to as an alias to an AWS resource, which is very, very good. So this is something that the exam may test you on, and we'll see this in hands-on. So on top of it, alias is very good because they're free of charge and they have a native health check capability within them. Okay, so if we look at these alias records in details, they are only mapped to resources in AWS. So you would say, okay, here is Route 53. I want to have example.com as an alias record of type A, and the value is the DNS name of the load balancer you have. Now, this is an extension to DNS functionality. It's not something that's across all DNS that exist out there. And in case the underlying ALB have IP changes, then automatically the alias record will recognize them. So as I said, unlike CNAME, alias records can be used for the top node of the DNS namespace called the zone apex. So you can use a alias record for example.com. Now, the alias records is always of type A or AAAAA, which is for resources, so either IPv4 or IPv6. When you have an alias record, you cannot set the TTL. It is set automatically by Route 53. So what are the targets for alias records? Well, it could be elastic load balancers. It could be CloudFront distributions. And some of these you'll have seen in this course. Some of this you will not have seen in this course, but this is fine. It's just for you to get an idea of what they can be. So ELBs, CloudFront distributions, API gateway, elastic beanstalk environments, S3 websites, so not S3 buckets, but S3 websites when these buckets are enabled as a website, VPC interface endpoints, global accelerator, and Route 53 records in the same hosted zone. One thing that is not there is that you cannot set an alias for an EC2 DNS name. This is something you have to remember. So EC2 DNS names are not something you can have a target, that can be the target of an alias record. Okay, just a little subtlety to know. So now let's have a look in the console to see how CNAMEs and alias records work. So let's go ahead and create.
Bro, this stuff is kinda annoying. CNAME, that's what CNAME records is. Shit, that always fucks me up. Yo, it's like 1 o'clock. I should go to sleep, man. Yo. Yo, dude, it's pretty cool. I'm liking this stream. It's pretty OP, dude. Got a pretty OP stream going in this bitch. You just gotta like be careful not to upset anybody.
So now let's have a.
I gotta finish this AWS crap. I mean, not this AWS, but this S3 shit. Do I have so much to go? Oh my goodness. Oh, latency, health checks. Oh my goodness. Gee, I got freaking. And there's a. That's so much fun. There's a Queens too. Oh my goodness. Oh, goodness. gotta do all this shit. There's so much to do. I'm only on. I gotta finish this because I have those S. I have like this EC. Oh, I should pause those EC2s. Nah, that's fine. I don't give a fuck. I don't give a fuck. Get this from. What this is? Yeah, I want my eraser. I'll be right back. I gotta grab my eraser. I need to grab my eraser. I bought a new eraser. I'm sick of just chocolate. Streaming, dude, work. So funny. What do I do with that eraser? Oh no. What the fuck? That's already there. Thirsty though. Throat. Where's that eraser? The eraser's supposed to be here already. Where'd I put it, dude?
So
Oh, bitch. Bought this eraser today. Master race my desk. All these lines. Okay. That's right there. Oh. Yo, dude. It's pretty badass. I'm just streaming AWS stuff. What are all the people learning, dude? Like, what are they, med students? I don't like how the people like do their. I don't know. Actually, I don't care. If I get in trouble, well, I had like 4 viewers at one point.
look at the differences between CNAME and aliases.
Oh yeah. CNAME and alias. Dude, I don't care how long it takes. I'm freaking getting through this AWS shit. I might have to be streaming this for like four, I mean, like, for a while. Might be streaming this for a while. I'll tell you that much. But this Route 53 stuff is all this stuff in this AWS stuff is huge. It's huge. Oh, this AWS stuff is huge. I bought 40 of these mechanical pencils today for $10. It's a pretty good deal. What is it, like 40 cents a pencil? I am just gonna be stupid, but 4 divided by 10 is no, it was 10 divided by 40. So yeah, so it was 25 cents a pencil. Yeah, so 25 times 40. Yeah, there we go. So yeah, I bought today 40 of these pencils, and each one of this was a quarter. 25 cents for this amazing pencil? Dude, that's a good deal, man. I like that. That was a good freaking stack. I got a stack of 40. Let me show it to you. Came in this cool box. Highly recommend. Yeah, pretty dope. I love these pencils. When I saw them, I'm like, yo, 40 pack of 40, dude. Are you kidding me, dude? And it was on Target for $10. And I went on Amazon, and Amazon was like 11. I'm like, okay, that's a good deal. Oh, fuck. But yeah, those pencils are the best. Okay. Yeah. Yo, streaming is so easy now. Holy crap. I can just stream on my work laptop. Like, I lose ping, yes. Gotta make sure not to trust this shit. That's setting so down. To auto stop. Why the fuck did they have that? Like, don't fucking, I didn't tell you fucking stop. Where was I? Okay. Tail B. DLB. Oh, okay, now I have to. Okay, so yeah, CNAME versus alias. That is the question. That's a really big question. Alias is lowercase, darn it.
So when you have an AWS resource, for example, a load balancer or CloudFront, it will expose a host name.
Oh man.
And what you want is to maybe map that host name to a domain you own. For example, you want to map this load balancer into myapp.mydomain.com.
Okay, so we know that yes, some AWS resources, AWS resources, load balancer.
So you have two options. The first one is to use a CNAME record. So
There'll be one, 4 dot us dash east dash 2 dot elb dot amazon dot com, and you want what do you want for Christmas? You want my just testing something real quick. Oh, so it's just perfect, dude. It's just like, all right, nice. Geeking out for a second.
as we'll see in the hands-on.
Only for
On the other hand, you have alias records, and these are specific to Route 53. But they allow you to point a host name to a specific AWS resource. So app alias.mydomain.com is pointing to blah blah.amazonaws.com. And these resources we'll see in a second what they are. But these alias records work for both root domains and non-root domains. So you can have my domain domain.com pointing to as an alias to an AWS resource, which is very, very good. So this is something that the exam may test you on, and we'll see this in hands-on. So on top of it, alias is really good because they're free of charge and they have a native health check capability within them. Okay, so if we look at these alias records in details, they are only mapped to resources in AWS.
Row 53 alias records. My question is, I don't understand why I have to put a CNAME record in GitHub pages. Like that C, what does that have to do with? CNAME posts a host name to any other host name. So in that case, my first host name is, I guess the host name for that is anti-surge.github.io. Okay, so this is a CNAME record. We're creating a CNAME record. This is gonna point to oh, I think I get it. Watch this. So watch this. Since I'm getting it now. Surge.link. That's my portfolio website. This surge.link is sitting up GitHub. No, I think it's that's suraction.github.io. Oh, this is my old portfolio. It's kind of cool. First portfolio ever, dude. It's kind of cool. I imagine this like to be like this, dude. It's so yeah, that was a lot. That was fun when I did that. I was so proud of myself. All right, so that's okay. So that's not the point. My point is, I need to get to GitHub. I need to go to asuroction./portfolio. No. So github.com slash. I need to check out. Are you like my project? Check this out. I made this project. I can't see because of my face. Well, anyways, I made this GitHub project, and this is what it's gonna be like. It's called a backside kickflip to crook. See, like, and that was like it's and so every day of the year he does like an animation, because last year I said coding is cool, but this year I have like this skateboarding guy doing a kickflip, and this is automated. Like, this is like a cron job in the cloud, dude. It's pretty sick. All right, so wait, okay, portfolio 2020. There we go. So this is portfolio 2020. That means I control T. It has to be github.com. Oh no, it's actually s Russian slash portfolio 2020. They should, yeah. That's exactly what it is. So this is a C. See how we have right? I'm getting it, dude. C name. C name right here. Search. So I have. So this C name record. Yes, I understand it now. C name points one host name to another. Example. We have a host name. This right here. Example. Host name su rockchin dot github dot notice not notice that it is not a root domain. It's a sub. So yeah, so my sub is so this is my slash portfolio 2020. So when someone accesses this, it's gonna go to search dot. It just goes to search dot link. Or yeah, and then this is just redirects to points. So this. So L surge link. Yeah, so this points to. I don't understand what's the CNAME. Well, the value of this CNAME record is yeah. So whatever. It's just saying right here when you get to here, it needs to yeah, something like that. I'm getting the understanding is getting close.
AWS. So you would say, okay, here is Route 53. I want to have example.com.
Yeah, this is really important. This record stuff are such a sore topic for me.
As an alias record of type A. And
So
and the value is the DNA. They are only mapped to resources in them. Okay, so if we look at these alias records in details, they are only mapped to resources in AWS. So you would say, okay, here is Route 53. I want to have example.com as an alias record of type A, and the value is the DNS name of the load balancer you have.
Oh boy. Ding, 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 ding. Man, I can't believe people are really good at hackering problems. Gosh.
Now, this is an extension to DNS functionality. It's not something that's across all DNS that exist out there.
Okay, so what happens is we get the alias record, right? Alias. Okay, so let me just draw this table because it's kind of helpful if I have this in the table form. You know what word I hate? Unfortunately. Ugh. You will never find me say that word. Use that word. Unfortunately. Ugh. It's freaking PR's favorite word. I mean, HR's favorite word. Unfortunately. God damn it. I wonder if they love using that word. Do people who say unfortunately, do they love saying that? I would imagine they would. You get like a little power kick out of it. Unfortunately. I'm just kidding. I don't fucking know. But I really don't like that word. It should be a joke. Ding, ding, ding. Ding, 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 ding. Ding, ding, ding. Ding, ding, ding. Ding, ding. Mm, 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 mm. I really get a kick of drawing these diagrams. It's probably the biggest waste of time. But tell you the truth, like these nose are sexy, dude. Look at these nose, man. I'm just like, oh, they look so perfect, dude. And he's gonna be for life. It's gonna be my AWS Solution Architect notes. And they're actually helpful for studying for the exams because what happens when I take the practice exams, I like take a red pen and then I go back the stuff that I miss on the exams. So then I like have like stuff that I need to watch out for. An exam's only 70% to pass, but at this rate, it's gonna take me like a week, like 2 weeks of full time job of doing this. And I'm gonna stream it all. It's gonna be funny. This is perfect, dude. That's why. That's cool. I like this application load balancer symbol. Oh, let me just put some more. You know what's really cool? Um, Thick paper. I like writing on thick paper. Okay, so application load balancer. Application load. IP addresses maintained. Do 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 do
And in case the underlying
I gotta draw my arrows.
ALB have IP changes, then automatically the alias record will recognize them. So as I said, unlike CNAME, IP changes that exist out there, and in case the underlying ALB
underline
have IP changes.
LB have in case the underlying ALBs have IP changes, in case underlying ALBs have IP
changes, then automatically the alias record
then automatically the alias record
will recognize them.
will recognize those IP changes. It's pretty cool. Pretty cool.
So as I said, unlike CNAME, alias records can be used for top for the top node of the DNS namespace called the zone apex. So you can use a alias record for the top node. As I said, unlike CNAME,
Zone apex. We now know what it is.
alias records can be used automatically. The alias record will recognize them. So as I said, unlike CNAME, alias records can be used for top for the top node of the DNS namespace. Alias records can be used for top for the top node of the DNS namespace called
Zone apex. So cool. I'm curious now what zone apex is. Let's see if anyone has a zone apex video. Zone apex record. Yeah, I don't want to play Apex Legends.
Super important for the exam. I'm logged into an account where I'm going to public IP address, but all I want
okay, so
the zone apex. So you can use a alias record for example.com. Now the alias records is always of type A or AAAAA, which is for resources. So so either IPv4 or IPv6. When you have an alias record, you cannot set the TTL. It is set automatically by route 53.
Set or managed by route 50. No problem.
So what are the targets for alias records? Well, it could be elastic load balancer.
Okay, so we'll get in some useful stuff for now. Alias records targets. Alias targets. Alias records targets. But whip it, whip it good. Whip it, whip it good. Whip it good. Round 53 targets. I'm bored. I'm like losing energy. Round 53 aliens targets. Okay, so we have elastic load balancers. Yeah. Man, fuck it. ELBs.
It could be CloudFront distributions, and some of these you'll have seen in this course. Some of this you will not have seen in this course, but this is fine. It's just for you to get an idea of what they can be. So ELBs, CloudFront distributions, API gateway.
Interesting. Yeah, this is like, what can I set example.com to?
Elastic Beanstalk environment.
What the fuck that is?
S3 websites.
Oh yeah, dude.
So not S3 buckets, but S3 websites. When these buckets are enabled as a website. VPC interface endpoints, global accelerator accelerator, and root 53 records in the same hosted zone. One thing that is not there is that you cannot set an alias for an EC2 DNS name. This is something you have to remember. So EC2 is that you cannot set an alias for an EC2 DNS name. This is something you have to remember. So EC2 DNS names are not something you can have a target that can be the target of an alias records. Okay, just a little subtlety to know. So now let's have a look in the console to see how CNAMEs and alias records work. So
Okay, let's go to the console.
let's go ahead and create a record, and this one will be of type CNAME. So I will call this one myapp.stefan.teacher.com, and the record type now is not A, it's not quadruple A, it's CNAME, and then the value must be a domain name. And very easy, I already have a domain name available, that's my ALB. So what I'm going to do is that I'm going to copy the hostname of my ALB and paste it in here. The idea is that now instead of accessing my ALB through this URL, I want to be access the ALB through myapp.stefan.teacher.com.
Cool.
Okay, so I will just create this record, and now myapp.stefan.teacher.com.
So you telling me this demo around 53 my ALB is gonna be like this now? Bruh. Nah. That's fire, dude.
Has been created. And so if I go into my Chrome web browser on the right hand side and open this URL,
That's pretty cool.
now you see that the answer is hello world from
Same
my
thing.
IP, blah, 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 in AZ EU Central 1C. So this domain name is in fact covered by the ALB, and the ALB is directing the traffic into one EC2 instance, and so therefore
Wait,
I receive back this hello
yeah,
world.
we need a
So this is good, but this is
CNAME.
not.
Ah, okay. This is perfect. This is a good example of CNAME. Okay. CNAME record. This is a CNAME. This is perfect, dude. CNAME record is just another host name to another host name. We have this host name, which is like a sub host name. That's what it had. A host name has to be a sub, and it points to this host name. Now, what we're gonna do is we're gonna change this host name to the ALB alias, baby. Oh, I get it now. It's gonna be cool. I can tell you what's gonna happen now. Okay, so CNAME practice CNAME record. So cool. I'm having like huge aha moments. Okay, so we have. Yeah, so we have. Okay, so record name. Let's do this. I like this. Record name. And then we do. Type. And then we do a value. Value. We're gonna go. Value. Record name. The record name is my app. My app dot lt surge dot com. It is a CNAME record. CNAME records, they have one host name. They don't post an IP address like a record. It points to another host name. And in this case, my host name is right. This is like a host name. Where is it? I'm watching where it is. Host name points to the ELB host name, which is. Let's just do one we have. Demo around 53 ALB. I made this one. Yeah, I remember. With Stefan. Stefan's cool dude. What a cool guy. He worked hard as fuck, dude. Is he like rich? I would imagine. 53 ALB round 50. No, not let's look. I want to dig. I want to dig into it. Dig. Yo, I'm having so much fun with this cloud thing. That's so cool, dude. Okay, so dig my. Let's see what my record is. Dig is a thing. Let's see what dig is. So I had dig dash. Oh, you don't have it. Alright, so I need to do sudo yum install dash y. I can do that. Sudo yum install dash y bind util. Yeah, bind dash utils. Okay, now we can do dig my app dot ltsurge.com. And this is gonna dig into the app, my app, the ltsearch.com record. It should be a CNAME record that points to my ALB. And what do we get? My app is ltsearch is a CNAME record that points to my ALB. Woohoo! Alright, called it. Okay, so first let's just practice this command. So what is it called? Sudo yum y, right? Example again. Sudo yum -y, and then we do something utils. Install utils, get utils. Fuck. Bind utils. I would never guess that. Bind utils. Then we do command dig my app.ltsearch.com, and then what we get is an answer, right? Yeah, answer section. Yeah, I'm liking this hacker stuff, dude. This hacker stuff is cool. Answer section. Answer section we have first. We first have. No, first we have. Okay, the way it works is my app. Yeah, answer section. My surge record name, and then it's gonna say 300. That's the TTL. And it's gonna say in. I don't know what in is. But then it's gonna say, okay, 300 in, yeah, CNAME, and then it's gonna say demo around 53. But this one is interesting. It's lowercase. It's all lowercase. Yeah, demo around 53 ALB. ALB. Yeah. Okay, so it's perfect. Query time, yeah, it's a query to the DNS. Okay, that's really cool. Okay, so now I know what's going to happen. He's going to be talking about, we're going to be, the next thing we do, since this is just a CNAME record, let's make a table of this. CNAME record. Man, I'm a fan of drawing straight lines. It's fun. It's like how I get my artistic kick just doing this. It's kind of fun, dude. Ain't gonna lie, it's really relaxing. And at the same time, learning so much cool shit, dude. That's like incredible. Okay, but the downside is kind of slow. That's okay.
not AWS native. Okay, this is something that will work for many domain names, but we can do something better because we are redirecting into an ALB. What we can do is create an alias record. So I can create a record, and this time it's going to be myalias.stefanteacher.com, and the record type is A because my ALB is currently having only IPv4 traffic, and the value of it. So we have to tick the alias right here,
Oh wow, it's huge.
and we're going to route traffic to, and then we have a list of options, okay? So as we can see, a lot of different options, but right now it's going to be an alias to an application and classic load balancer. We need to choose a region, so it is in EU Central 1 for me. And then we need to choose the load balancer, so I will choose this load balancer right here. Then automatically we can evaluate the target health as well with a yes, because this is an alias record. So we'll click on create this record, and now I have a new record right here called myalias.stefanteacher.com. And now, because this is an alias, then, and then we need to choose the load balancer. So I will choose this load balancer right here.
So sick.
Then automatically we can evaluate the target health as well with a yes, because this is an alias record. So we'll click on create this record. And now I have a new record right here called myalias.stefanteacher.com. And the cool thing is that this record is free to query. Okay, so I'm not going to pay any money because this is an alias record.
Cool. Okay, so okay, so if I go like this, he's saying that it's gonna work. Oh, nice. What if I did dig? Yeah, it's an A. Oh. Yes, this is cool. This is CNAME with that, but this is now my alias. I'm guessing this is like the public. This is the IP of the load balancer. Yeah, it's right here. Oh, okay, so it's the same thing. I just dig those in. Okay. Well, it's this dig thing is kind of cool. Okay, but this is even better, yeah, for sure, because now I have my alias is an A. It's an A record. Yeah, so don't remember. Remember surge. Alias record is type A or quad A because points directly to IP. Yeah, it's really good. I like alias records. They're cool. Let's fucking throw, dude. They're A records. Alias for A record. Oh my goodness. Alias. A records. Wow. Mind blown. All right, what else you got for me, Stefan?
So if I click on myalias.stefanteacher.com, it's going to perform a few DNS queries, and now again I get the same response. Again, nothing has changed, but it is working. Okay, so that's perfect. But now what if we consider the domain apex? So if we want to have just stefanteacher.com to redirect to this page. So what we're going to do is create a record. And let's go ahead. So we're going to just have nothing in here. Okay. And we're going to have a CNAME record pointing to the domain name of my ALB, which is copied from here and pasted in here. Okay. So we want to say, hey, Stefan.teacher.com is going to be a CNAME for this value. Now this is not going to work. Let's try it. It's saying, hey, bad request. The CNAME is not permitted at apex of this zone. So this zone is Stefan.teacher.com, and the apex of the zone is Stefan.teacher.com, and therefore we cannot set up a CNAME at the apex. So the only way we can deal with this issue is instead to create an alias, and the record is going to be of type A, and the alias is going to point again to an ALB or CLB. The record is going to be of, and deal with this issue is instead to create an alias, and the record is going to be of type A, and the alias is going to point again to an ALB or CLB in the EU Central 1 region, and the load balancer is going to be the one from before. Now this is going to be accepted because this is an alias record, and this is what the exam may test you on, okay? And so now we can see that Stefan.teacher.com is accessible. And so if I go back into my web browser in here, open a new tab and enter stefan.teacher.com and press enter, here I get back the hello world from my load balancer, so everything is working great. So that's it. We've shown how CNAMEs and alias records work in AWS. I hope you liked it. And
I gotta double check. One only thing I want to do is check my load balancer and see what this corresponds to. Which one of these is the load balancer IP? Well, or maybe it's an instance because it's going to point to the instance. Probably instance and load balancer. Let me see this. Load balancers. Does it have like a kind of IP thing? IPv4. Got a hosted zone. Okay, I understand that. How do I see attributes? What IP4 it is? Yeah. Okay, I guess it doesn't tell me. Okay, maybe I can look at. I know it's connected to a target group. So let's go to demo target group, and I want to look at this EC2. Yes, perfect. And now this is probably it's got some IPv4 that I'm interested in. IPv4 317. Oh, it's probably maybe it's in. Oh yeah, IP public private. Well, that one is popping up a lot. Well, whatever. I don't care. I got
I will see you in the next lecture.
Wait, what? Yeah, I do like it.
Now let's talk about routing policies for Route 53. So a routing policy is helping Route 53 respond to
Okay, routing policies. Oh, how much do we have left to see this? I want to see how. Okay, we had 107. I get to 117. Oh, section clean. I definitely need to get to the cleanup. The cleanup prenup. Yeah. Routing policies.
DNS queries, and we shouldn't be confused about it is helping Route 53 respond to DNS for Route 53. So now let's talk about routing policies for Route 53.
Yeah, this is kind of important. Anything to do with policies is always important. Routing policies.
So a routing policy is helping Route 53 respond to DNS queries. And we shouldn't be confused about the word routing. Okay, this is not like when you have a load balancer and the actual load balancer will route traffic to the backend EC2 instances. No, no, no. This routing is from a DNS perspective. So the DNS does not route any traffic. So the traffic doesn't go through the DNS. The DNS only will respond to the DNS queries, and then the clients will know to which way they should be doing these HTTP queries, for example. Okay.
DNS does not route any traffic. DNS only responds to DNS queries. It's huge.
So the DNS just helps translate host names into actual endpoints that the clients can use. Okay, so Route 53 will support the following routing policy. There's simple, weighted, failover, latency-based, geolocation, multi-value answer, and geoproximity. And we're going to have a look at all of them in this section, okay? So the first one is going to be the simple routing policy. And the idea is that this
Look at all of this section. I can't do it. I'll have to take a break. And I think in order for that, I need to pause my instances. Let's do a little cleanup. I'm just gonna pause the instances. Alright, I need to go to bed. This is like way too late. Can't do this right now, dude. I did a lot. Stream for like. Alright, so yeah, I need to go to bed. Okay, first let's do this. Let's go. That we're gonna go to instances. There should be 3. 1, 2, 3. Let's go to instance. We're gonna stop this one. It's gonna stop it. Stop instance. And then we go here, instances. This is not the little now. Stop in the name of money before you charge me, honey. Honey is money. I could have said money. Instant state. I'll stop instance. Okay. fine. Oh, I have that load balancer too. Let's check it out. I don't know what load balancer's prices are, but I'm gonna pause the load balancer. Yeah, dang. No, yeah. Oh. I don't want to delete it. It's okay. Let's check it out. I want to see what the free tier is for load balancers. Application load balancer free tier. I am fucking fine. If anything, I'll be running. Well, let's go check out. Let's have some fun. Let's see what my billing is like. Just don't be afraid to use services. That's what they're for. Billing. What? That's a lot. That's not free. Oh yeah, because so we do 750. What is it? 750 divided by what? 31. 25. No, I know. So it's 7. What do I do in 24? So dumb. 50 divided by 31. Yeah. So it's 24. Oh, okay. So I got 0.9 times 0.2 times 31. I have 6 hours of running this ELB. Yeah, it's fine. I can run it for 6 more hours. That's God damn it. I only have 6 more hours of this. Oh, I gotta do all of these. Screw it, we're getting through this. Let me turn it back on. And I want to finish this. I want to get to we get to this part, section cleanup. So we're gonna fucking turn these back on, instance state, start instance. Okay, we're starting.
With this that we've actually been using before, we're going to route traffic to a single resource typically. So here's an example. The client will say, hey,
It's a simple routing policy, but it's not really routing because we're not on we're not at the HTTP layer. We're at the freaking the query, domain query layer. Simple routing policies typically route traffic to a single resource. To the policy, like, hey, you can only go to this.
I want to go to foo.example.com, and Route 53 will say, hey, go to this IP address, and this is an A record.
A record.
So it is possible for us to specify multiple values in the same record. And if so, if multiple values are returned by the DNS, then a random one will be chosen by the
That is so trippy. Client wants who.example.com. Amazon is gonna give them multiple values of the A record. Huh. Multiple values are returned. A random one is chosen by the client. That is so trippy. A random one is chosen by the client. I need to write that as is. If multiple values are returned, comma, a random one is chosen by the client. Damn, and the client word is underlined. That is called a simple routing policy with multiple values. Wow. Doesn't sound very simple, that's for sure. Nice. Simple routing policy with multiple answers. Dude, I like this camera view I got. It's pretty freaking funny. Ooh, hands, magic hands. Watch the hands here, then hands here. Can I get 4 hands? It's kinda it. It's like really hard to match it. Okay, I wonder if I can shake my own hands. Oh yeah, that's a transfer right there. You go like this. Yeah. 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 Now you see me? Now hands go like this. It's actually pretty trippy. I'm tripping out. It's funny as hell. It's like it's perfect actually. It's pretty fucking funny as hell. Yo, hands. You wanna see my zoomed in hands? Look how big my fists are. Look at that huge. Look at that crossbones. Yo, check out my huge arms. My arms are so huge, they spam the cameras. Bruh, dude. Oh, fuck. Late night fucking highness is great. It's fucking hilarious. Okay, that's gonna be the highlight too. Yo, ladies. What was I doing? I was getting baked. Oh yeah. This thing's gonna return you the multiple values. I got to draw the multiple values. Multiple values. Yeah. It's gonna go like 1, 2, 3, right? Yeah, no, he's gonna do one arrow, but 3 values. Yeah. It should be one arrow. But it has AAA. I need to add little sub A's to here. AAA 11.2233. Yeah, is it kidding? 1, 2, 2, 3, 3, 4, 5, 5.66, 7, 8, 9, 9.11.22.3. It's just like, okay.
And then the client will pick one of them randomly and apply it for the routing. So if you have enabled an alias record alongside the simple policy, then you can only specify one AWS resource as a target. And finally, it's policy. Then you can. So if you have enabled an alias record alongside the simple policy, then you can only specify one AWS resource as a target. And finally, it's called simple because it's very simple, and therefore you cannot associate this with health checks, and we'll see health checks later on in.
Simple policies are not associated with health checks.
In this section.
Health checks are complex.
And how they work, okay? So let's go in the console to see how a routing policy of type simple can be created. So let's create a record, and the record name is going to be simple.stefan.
Create a record. Create a record called simple. Oh yeah, more records? Dude, how many records are there, man? Holy crap. fuck done?
T-
Okay, Simba.
T-shirt.com. It's an A record, and the value of which is going to be, for example, my instance in AP Southeast 1. Now for TTL, I will say something very low, like 20 seconds, and the routing policy is to see how a routing policy of type simple can be created. So let's create a record. And the record name is going to be simple.stefanotshirt.com. It's an A record, and the value of which is going to be, for example, my instance in AP Southeast 1. Now for TTL, I will say something very low, like 20 seconds, and the routing policy is going to be here. So as you can see, we have different possibilities, 6 of them, and then one other that is somewhere else in the UI. So we have a TTL 20 seconds, a simple routing policy, and let's just create this record. So we've been doing this before. We know how this works. So now if we go to simple.stefanotshirt.com and go to this URL, we get hello world from my instance in AP Southeast 1B, which is awesome. And if we do a dig command and have a look, so we need to reinstall.
Ah, man, I stopped and started my instances, so I think they changed. It's okay, so I need to go. It's okay, at least I know what's up now. Alright, so Ohio. Yes, they changed. Yes, East is. Oh. Am I doing this right? Yeah, I'm good, yeah. Okay, so I need now. The third instance I need to change is right here. And I need to change this to that. And now I also need to change my record now. That was a mistake. I need to edit this. Edit, select, edit record. Yes, save. Now this same thing should work just like before. Perfect, dude. I'm so good at this now. Hell yeah. Okay, so now we just gotta do this. And we gotta go here. Connection lost. It makes sense. That means I have to do the yum thing. Because watch, if I do dig, it's not gonna work. And it's gonna be yum install bind utils or something. Dang, this thing takes a while. Future notice, get a cloud shell running right away. Yum install dash y find utils. Oh yeah, I need to do sudo. That's right. Perfect. And then I do dig. Simple, yeah. Dig simple dot ltsurge.com. Well, what does he want to do with this?
Install dig, so sudo yum install. Okay, so we're going to redo the dig command. So we do the dig command on this. As we can see, we have an A record of a TTL of 20 seconds pointing to this IP.
Yeah.
But we can change this record now. We're going to.
So I see 20 seconds pointed to this IP, and this IP is the one that we just set up right here in simple.
To edit the record, so I will just simply click on it and edit the record. And for the value now, I can enter multiple IPs. So I can enter my one in AP Southeast 1 or one in US
cool.
East 1 for
Multiple IPs, eh? Okay, so let's do this. Oh, and then it's gonna show up random ones? Sick. Watch this. That is so cool. Okay, and then let's do the third one. That's pretty cool. I get this. This is a simple record with a policy, simple routing policy with multiple values. Alright.
for example. So when I do so and save this, what's going to happen is that once the TTL expires from before, we're going to get two records back. So let's use Cloud Shell to verify this. So I'm going to do a dig command. And as you can see, now we have in the answer section, we have two responses. We have one in this IP and one in this IP. So it's a client-side choice. So that means that if I go to this website and refresh, I have one chance out of two to go into US East 1, and I didn't. So I was back into
Wait, I'm not getting it. It should be
AP 1 in the MV expired. So when I do so and save this,
I think I got a little greedy here. You said just to do two. And then you have to wait 20 seconds. Okay, so okay, so I gotta wait 130 seconds or something. Cause it's still showing up the 18. Let me see what this is saying. Did I do a TTL? Oh, see, no, I did the, 20 seconds. Okay, so let's try this again. Give me a different one, you asshole.
what's going to happen is that once the TTL expires from before, we're going to get two records back. So let's use Cloud Shell to verify this. So I'm going to do a dig command. And as you can see, now we have in the answer section, we have two responses. We have one in this IP and one in this IP.
My goodness, it's not fun. I gotta wait a whole minute. Ah, freak. Alright, fine. I'll wait a minute. Okay, better do it now. Let's see, we have 10. If it goes to like not 20 for the TTL, I'm gonna be pissed. Yes, oh, there we go. See, perfect, 2. Sick. But why does it go to... Like, I do 20, and now it just goes back to... It's supposed to be... Oh, whatever. At least it gave me 2.
So it's a client-side choice. So that means that if I go to this website and refresh, I have 1 chance out of 2 to go into US East 1, and I didn't. So I was back into AP Southeast 1B, but let me pause for 20 seconds and I'll get back to you. And
Well, I did. I had 1 out of 2, and I
now I'm
got
refreshing,
it.
and I get back the hello world from US East 1A. So this worked. This absolutely...
Oh, that's kind of cool. So, the TTL... Well, my TTL is like... Not 20 seconds. It's like 3... It doesn't do 20 seconds. My TTL's dumb. And it goes to like... Back to... I don't know. I just guess it doesn't like... Well, it switched. I got lucky.
shows how simple records work. I hope you liked it, and I will see you in the next lecture. So now let's talk about the weighted routing policy. The idea is that you can have a percentage of requests you can control to go to a specific resource thanks to weights. So put it simply in the diagram, we have Amazon Route 53, and then we have 3 EC2 instances that have been assigned different weights. So 70, 20, and...
Where it switched, we all saw it. A 50% chance, and it switched because you had 2 different IPs now. Now we're going to talk about weighted routing policies, okay? Route to weighted. Oh, you get to see this lecture. Nice. Routing policies weighted. Oh, weighted. Weighted. Routing policies weighted. Control the percent of the requests that go through. Okay, so control the percent of the requests. Percent of.
and 10. In my example, these weights sum up to 100, but you don't have to in the real life, okay? But what this means that 70% of the DNS responses from Amazon Route 53 are going to be redirecting to the first EC2 instance, then 20% to the second, and 10% to the third. So what we have to do in our way is to assign each record a relative weight. And then the traffic percentage is going to be sent to each record is just the weight of the record divided by the sum of all the weights of all the records, which is like a percentage of all the weights, okay? The weights don't to sum up to 100, they're just indicative of how much we want to send to this instance compared to all the other records in your DNS name. So to make this work, the DNS records must have the same name and type, and you can associate them with health checks, although we haven't seen what health checks are again yet, but we'll have a look at them very, very soon. Now, the use cases for a weighted routing policy is pretty obvious, is to do, for example, load balancing, maybe across different regions, or to test a new application version by sending a small amount of traffic to it. and so on. And then if you assign a set of a weight of 0, then you're going to stop sending traffic to a specific resource, so you can shift weight over time. And if all the resource records will have a weight of 0, then all the records will be returned with equal weights. So let's have a look in the console to see how that works.
It's pretty heavy stuff, dude. I think I'm done with that load balancer too. I don't need that stupid load balancer. I just go to bed. Puzzles instances don't have a load balancer. Load balancer for a month. If I make a new one. Actually, no. Load balancer is connected to all of those records too. What I need is like a little energy boost. I gotta do that. I gotta get a snack of food. I need to take a break, a Twitter break. Damn, it sure likes steak. AWS stuff is tough, dude. I learned a lot of valuable policies today, though. Not policies, but concepts. A lot of valuable concepts. I gotta say, by far, the most important concept I learned today was CNAME, aliases, and A-name records. What they all mean. A record, it points to an IP address, IPv4 or IPv6, a quad A record. And CNAME is a record that points one domain name to another domain name. And it actually has to point, it has to come from a subdomain name to begin with, to point to another domain name. But an alias record, you can have it, it's a unique A record. It's only for AWS. And an A record, you can attach it to a resource, an AWS resource, like a load balancer or gateway, but you cannot attach it to an EC2, because an EC2 is the most, well, yeah, you just can't, but you can attach it to a load balancer, and if an underlying load, yeah, because it attaches to the the domain name. Record to that. Yeah, but the C record part is kind of cool. Now we're talking about policies, and now there's like a weighted policy. Oh, it's interesting.
returned with equal weights. So let's have a look in. So to make this work, the DNS records must have the same name and type, and you can associate them with health checks, although we haven't seen what health checks are again yet, but we'll have a look at them very, very soon. Now, the use cases for a weighted routing policy is pretty obvious, is to do, for example, load balancing, maybe across different regions, or to test a new application version by sending a small amount of traffic to it, and so on. And then if you assign a set of a weight of 0, then you're going to stop sending traffic to a specific resource, so you can shift weight over time. And if all the resource records will have a weight of 0, then all the records will be returned with equal weights. So let's have a look in the console to see how that works. So let's create a new record, and this one is going to be called weighted.stefanoteacher.com. It's an A record, and the routing policy is going to be weighted. So first, for the first value, let's enter the one from AP Southeast 1. And the weight I'm going to assign to it this time is going to be 10. Okay, so a very, very small weight. For the TTL, I'm going to set it to something really low, 3 seconds, to just show you the impact of weighted. But obviously, this is not a TTL you would use in real life. So as we can see, we can associate a health check with it, but for now we won't. And we have a record ID that we can set, and this is to identify this specific record within the weighted record sets. So for this one, I got this instance from the Southeast, so I'm just going to write Southeast. Okay. And then we can add another record. And again, Okay. And then we can add another record. And again, we're going to use the same weighted.stefan.teacher.com, okay? And the routing policy is going to be weighted, and the value of which is going to be the one from US East 1. So I'm going to copy this IP and paste it here. The weight is going to be, on this time, 70. So we're going to send 70% of the traffic to US East 1, and then the record ID is US East. Great. And the TTL, again, 3 seconds. And one last record we're going to add. So again, weighted, and then the value of which is going to be EU Central 1 in here. And I'm going to send it as a weighted record. I'm going to send 20 as a weight, and the record ID is going to be EU. Okay, and the TTL, 3 seconds. So now let's go ahead and create these records. And as we can see, we now have 3 create these records. And as we can see, we now have 3 records in this table, okay? So this is why it's different from, for example, a simple record that had 2 values. Here we have 3 records, and each record has 1 value as an answer. But we have a weight of 10, 20, and 70. So if I go to the URL now, if I go to weighted.stefan.theteacher.com and press enter, I'm getting a first response from US East 1A, which makes sense because, well, this is where 70% of the traffic is supposed to be going, okay, to this region. But if I refresh, and I need to refresh maybe every 3 seconds, at some point, I should be getting a response from another region. And this is just based on weight. So this is the whole idea behind weighted resources. So as you can see, this one is not changing a lot. So let's do a dig command just to show you the output of what it is. So dig weighted.stefan.theteacher.com. And here we get a TTL of 3, and the answer is, I think, still the one from US East 1. But so let's try to issue one more and see if we get any luckier. So the weight of 70 definitely is a big weight. Okay, but here, as we can see, we just got an answer, and this one is a different IP, 3.70.14, which is corresponding to the weight of 20. So as we can see, weighted does exactly what it's supposed to do. It's redirecting most of the queries into the one that has the most weight, but from time to time, you will get other answers, okay? And so on. So this is something you can practice in your web browser as well. As you can see, cool, I just got redirected into EU Central 1C. So that's it for this lecture, and hopefully it shows you the power of weighted records. I hope you liked it, and I will see you in the next lecture.
It's not really doing it for me. Well, that's right. At least it's working. So one east, which is my one east here, yeah. And my 1 east 395 is 70% weighted. Yeah, let's. I wonder if I can. Just if I do this, edit record 70. Yeah, and I go here 395 188. It's just not changing. It's just the TTL is dumb. It doesn't. It's not right. It doesn't. You can't set the TTL low. Okay, whatever. But it's maybe I get lucky. I got lucky that one time. And it's not gonna work because I have to wait. Let's see. 24, 52 minutes. Let's try in 2 minutes. In 2 minutes, I'm surprised. Oh, I mean, it makes sense. It's not even gonna work unless I do this. Watch this. Unless I go.
Let's talk about a route.
Watch this. I'm gonna do something really cool. Wait. I'm gonna make this 0. All right. Now. Yeah. So now for sure, in 120 seconds, when this thing dies, you should not include that at all. We just learned that.
Routing policy.
Okay, now let's go to routing policies. This is latency based. Okay.
That's super easy to understand, which is the latency-based routing policy. Okay, so now let's talk about latency-based routing policies. And the idea is that you want to redirect to the resource that is going to have the lowest latency, so the closest to us.
Okay, let's double check this guy. It's still giving me 395, but in 5 seconds. 3, 2, 1. Yes! See? Now it's 3. Yeah. Okay, so it had a 3-second thing for a second. Alright, so now we go here. Failsafe. Yep. I understand it. I called it.
Which is super helpful when latency is your main concern for your websites or applications. Now, latency is going to be measured based on how quick it is for users to connect to the closest identified AWS region for that record. So, for example, if you're in Germany and you have the lowest latency to a resource in the US, then this is where you'll be redirected. And this can be combined with health checks that we'll see in the very next lecture. So let's have a look at the map.
That's kind of cool.
Map of the world to understand it. Say we deploy. Our applications in 2 different parts of the world. And the record name is going to be latency.stefan.teacher.com. And the first value is going to be the one in AP Southeast 1. So I'm going to paste the value in here. And then the routing policy is going to be latency. So when we do this thing, because we just put an IP address in here, we need to specify the region of our record. So this one is going to be corresponding to AP Southeast 1, which is Singapore, okay? And the reason is that AWS is not smart enough, at least in this stage, to take this IP and know that it comes from an EC2 instance that I have in Singapore, because it could be any IP in the world, actually. So it's for us to specify, hey, this IP corresponds to the region Asia Pacific, Singapore. And then we can associate a health check and a record ID. So I'll call this one AP Southeast 1. And it's just a name that I give it. Now we can add another record. Again, the record name is going to be latency, and the value of which this one is going to be for US East 1. So I'll have the value here, and it's going to be weighted. No, latency, excuse me, of course. And then it's US East 1. And again, I will just have it as US East 1 for my record ID. And then one last record is going to be for EU Central 1. So I will copy this IP, and the record name is this. The value is here. The routing policy is latency, and the region is EU Central 1. So will be the name. Okay, so as we can see, we have 3 records being created, successfully created, and they sit right here. And so now let's try them out. So right now I'm in Europe, and so if I open this, I'm expecting it to go to my instance in Europe. So I go to this URL and I get a response hello world from this IP in EU Central 1C. If I use Cloud Shell to try it out and we do a dig command on this, as we can see, we get an error record back of just one value. Okay, so just one value of the same IP address as this one. So this is my instance in EU Central 1C. And if I keep on refreshing, well, because my latency hasn't changed to EU Central 1, I'm going to get always the same answer. Okay. But how do we test whether or not the latency record is working? Well, for this, I can use a VPN. And so let's go to Canada, for example. And in Canada, well, it turns out that my latency is going to be the closest to the US. So if I refresh this page now, I get closest to working. Well, for this, I can use a VPN. And so let's go to Canada, for example. And in Canada, well, it turns out that my latency is going to be the closest to the US. So if I refresh this page now, I get the hello world from the US. And when I did change my location thanks to the VPN, it cleared all the TTL that I had for my DNS cache locally on my laptop. And so this is why automatically by refreshing it, I was able to get the newest value for US East 1A. But again, if I use dig, because this hasn't changed, okay, my Cloud Shell is still in Europe. Okay, if I use the dig command and use the exact same command as here, I'm still going to get the exact same value as before, okay? Because, well, this computer right here, this Cloud Shell, sits in EU Central 1, and so this is still the closest location to EU Central 1. And how do we test the one for AP Southeast? Let's go into Hong Kong. Okay, so I'm close to Singapore now, and I will refresh this. And the answer is hello world from AP Southeast 1B. So the latencies record are working, and they're really, really good and very common to use online. I hope you liked it, and I will see you in the next lecture. So let's talk about health checks in Route 53. So health checks are a way for you to check the health of mainly public resources. Although there's a way for us to do it for private resources as well, as we'll see in this lecture. So the idea is that, for example, we have two load balancers in different regions, and they're public load balancers, okay? And behind the scenes, we have our application running in both of them. So we're running into a multi-region setup because we want high availability and so on at the region level. Then we're going to use Route 53 to create DNS records. So that's when users access our URL, for example, mydomain.com, then they get redirected to, for example, the closest load balancer they have. So this would be the case with a latency type of record. But we want to make sure that if one region is down, then we don't send our users to that region, obviously, right? So to do so, we're going to create health checks from Route 53. So we'll create a health checks on the one in US East 1, and we will create a health check on our instance in EU West 1. Well, with these two health checks, we're going to be able to associate them with our Route 53 records. And the reason we do so is to get automated DNS failover. So we have three health checks that are possible. The ones I just showed you, which are the health checks that monitor an endpoint, which is a public endpoint. So it could be an application, a server, or another AWS resource. It could be a health check that monitors other health checks, also called a calculated health check. Or it could be a health check that monitors a CloudWatch alarm, which gives you more control and is helpful for private resources, as we'll see in this lecture. Finally, these health checks have their own metric, and you can view them in CloudWatch metrics as well. So let's look at how health checks work with a specific endpoint. So if we have a health check for EU West 1 for an ALB, so let's talk about health checks in Route 53. So health checks are a way for you to check the health of mainly public resources, although there's a way for us to do it for private resources as well, as we'll see in this lecture. So the idea is that, for example, we have two load balancers in different regions, and they're public load balancers, okay? And behind the scenes, we have our application running in both of them. So we're running into a multi-region setup because we want high availability and so on at the region level. Then we're going to use Route 53 to create DNS records. So that's when users access our URL, for example, mydomain.com, then they get redirected to, for example, the closest load balancer they have. So this would be the case with a latency type of record. But we want to make sure that if one region is down, then we don't send our users to that region, obviously, right? So to do so, we're going to create health checks from route 53. So we'll create a health checks on the one in US East 1, and we will create a health check on our instance in EU West 1. Well, with these two health checks, we're going to be able to associate them with our route out 53 records. And the reason we do so is to get automated DNS failover. So we have three health checks that are possible. The ones I just showed you are the health checks that monitor an endpoint, which is a public endpoint. So it could be an application, a server, or another AWS resource. It could be a health check that monitors other health checks, also called a calculated health checks, or it could well, with these two health checks, we're going to be able to associate them with on the one in so we're going to create health of them. A way for you to check the health of mainly public resources, although there's a way for us to do it for private resources as well, as we'll see in this lecture. So the idea is that, for example, we have two load balancers in different regions and they're public load balancers, okay? And behind the scenes, we have our application running in both of them. So we're running into a multi-region setup, okay? For example, we have two load balancers in different regions and they're public load balancers, okay? And behind the scenes, we have our application running in both of them. So we're running into a multi-region setup because we want high availability and so on at the region level. So we're running into a multi-region setup because we want high availability and so on at the region level. Then we're going to use Route 53 to create DNS records. So that's when users access our URL, for example, mydomain.com, then they get redirected to, for example, the closest mydomain.com to create DNS records, so on at the region level. Then we're going to use Route 53 to create DNS records. So that's when users access our URL, for example, mydomain.com, then they get redirected to, for example, the closest load balancer they have. So this would be the case with a latency type of record. But we want to make sure that if one region is down, then we don't send our users to that region, obviously, right? So to do so, we're going to create health checks from Route 53. So we'll create a health checks on the one in US East 1, and we will create a health check on our instance in EU West 1. Well, with these two health checks, we're going to be able to associate them with our Route 53 records. And the reason we do so is to get automated DNS failover. So we have three health checks that are possible. The ones I just showed you, which are the health checks that monitor an endpoint, which is a public endpoint. So it could be an application, a server, or another AWS resource. It could be a health check that monitors other health checks, also called a calculated health check, or it could be a health check that that monitors a CloudWatch alarm, which gives you more control and is helpful for private resources, as we'll see. In this lecture. Finally, these health checks have their own metric, and you can view them in CloudWatch metrics as well. Finally, these health checks have their own metric, and you can view them in CloudWatch metrics as well. So let's look at how health checks work with a specific endpoint. So if we have a health check for EUS1, for an ALB, then the health checkers of AWS are coming from all around the world. So it's not just one health checker, it's about 15 health checkers from all around the world. And they're all going to send requests into our public endpoint to wherever route we set. And then if it gets 200 OK code back, or the code we defined, then the resource is deemed healthy. So about 15 global health checkers will check the endpoint health. And then you can set a threshold for healthy or unhealthy. You can set an interval. So we have two options. It could be either 30 seconds for regular health checks or every 10 seconds, which is a higher cost, which is what's called a fast health check. It supports many protocols, so HTTP, HTTPS, and TCP. And the rule is that if over 18% of the health checkers say that the endpoint is healthy, then route 53 will consider it healthy. Otherwise, it's deemed unhealthy. And you have the ability to choose which locations you want to use for the health checks. Now, the health checks will only pass if you have the status 2XX or 3XX status code back from the load balancer. And the health check has a cool capability. So if it is a text-based response, then the health checkers can check the first 5,120 bytes of the response to look for some specific text in the response itself. Finally, very important from a network perspective, if you want for it to work, obviously, the health checkers must be able to access your application balancer or whatever endpoint you have. And so therefore, you must allow incoming requests coming from the route 53 health checkers IP address range. And you can find this address range at the URL in the bottom right of the screen. Now, the second type of health checks we have are calculated health checks. And so this is to combine the results of multiple health checks into a single health check. And so if we look at Route 53, with 3 EC2 instances, we can create 3 health checks. They're all going to be children health check, and they can all monitor each EC2 instance one by one. And then we can define a parent health check, which is going to be defined on all these child health checks. And so the conditions to combine all these health checks could be an or, an and, or a not. You can monitor up to 256 child health checks, and you can specify how many of the health checks need to pass to make the parent pass. So the use case for this would be to, for example, if you want to have a parent health check to perform maintenance on your website without causing all the health checks to fail. And so how do we monitor the health of a private resource? So in case you want to monitor something private, it's going to be difficult because, well, all the Route 53 health checkers live on the public web and they're outside of your VPC. So they cannot access private endpoints. So if it's a private VPC or an on-premises resource. And so the way we can do it, though, is to create a CloudWatch metric and assign a CloudWatch alarm on it. And then you can assign the CloudWatch alarm into the health checker. So the idea is that we're going to monitor the health of our EC2 instance in a private subnet with a CloudWatch metric. And then if the metric is breached, we're going to create a CloudWatch alarm on it. And when the alarm goes into the alarm state, then the health checker is going to be automatically unhealthy. And therefore, we'll have created exactly what we want, which is a health check on a private resource, which is the most common use case on how to do it. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So let's go ahead and create some health checks. So on the left-hand side, I'm going to go into the health checks, and we're going to create health checks for all our EC2 instances. So we're going to make 3 health checks. So the first one is going to be for my instance in US East 1, and it's going to be an endpoint. And then you need to specify either an IP address or a domain name. So we'll keep it as an IP address, and my instance in US East 1 is right here. So I will paste that in. We have to specify a port. So we'll keep it as 80 because this is the HTTP port. And for path, we're just going to be keeping the path as slash because, well, this is the same as the IP slash, which is the root of our website. If we had a real application, sometimes it is very common to have a path slash health, for example, which responds with the health of the endpoint itself. Okay, so we have this ready. So I will just remove the slash health. And then we can look at some advanced configurations. So we can have either a standard every 30 seconds or a fast every 10-second type of health check. We'll keep it as standard because this is otherwise more expensive. How many times it needs to fail before being considered as a failure? Do you want to do string magics, or do you want to look for a string in the first 5,120 bytes? Yes or no. Do we want latency graphs? So to see whether or not, to get to see how latency evolves over time. Do we want to invert the health checkers? So do you want a healthy to be unhealthy and vice versa, or disable it? And then do you want to customize the regions of the health checkers, or do you want to use a recommended? And we'll just keep it as is with using recommended. So every option is pretty much as default. And do we want to be notified whenever this health check fails, yes or no, by creating an alarm? I will just say no for now. So we have created our first health check. Now let's create our second health check. And it's going to be for AP Southeast 1. So AP Southeast 1. And then IP address right here, not host name. And then next and create. And the last health check is for EU Central 1. So let's create this health check. And I will name it EU Central 1. And then here is the IP address. And click on next and create health check. Okay, so our health checks are now created. And what I'm going to do is that I'm going to go to one of my instances, for example, the one in Singapore. And for the security group, I'm going to start blocking the port 80, removing this rule. And the idea is that I want to get a failing health check. So I'm going to go into the security group right here. I will do action and edit the inbound rules. And I will delete my HTTP-based rules. And what this will do is that the one health check for AP Southeast 1 should give me a unhealthy status. So let me wait a little bit for the health checkers to do their thing, and I will get back to you. Okay, so as we can see, we have 3 health checkers, and one of them is unhealthy, obviously, because I locked the security. security group, and the other two are healthy because I didn't change the security group of them. So we can have a look at the health checkers and they give you some information around when it was last checked. And so on. And for the unhealthy one, we can view the error status. So if we look at view last failed check, we can see that there was a connection timeout and maybe the requests are being blocked by my firewall, and firewall is your security group. So that makes sense. So at least it gives us some information and they are working just as expected. And one last thing that you can create is a create a health check. And this one is going to be a calculated health check. Calculated, here we go. And the is going to check for the status of other health checks. And now we can specify with which health checks we want to monitor. And okay, we're saying maybe you want to report healthy when one of the three health checks are healthy, or when two, or when all of them are healthy. So this is an and, or one or more health checks are healthy. So this is or alarm. In which case we need to specify the. Okay, so now let's talk about routing policies, and this one is going to be for the failover. So the idea is that we have root 53 in the middle, and we have two EC2 instances. One is going. Okay, so let's clean up what we've done in root 53 if you wanted to avoid some costs. So the domain name that you've bought, of course, stays in your account, and it will cost you $12 a year if you wanted to renew it, or more if you've bought a more pricey domain name. The domain name itself, so the hosted zone, if you're not using it, you can delete this hosted zone by first emptying all the records. Otherwise, it will cost you 50 cents per month to keep this hosted zone alive, okay? Within it, it doesn't matter if you have many records, you can just leave them as is. This is fine. The other thing we have to delete is all our EC2 instances in our different regions, as well as our ALB. So we had EC2 instances in 3 different regions. So what I'm going to do is just delete them one by one. So there was one from me in Frankfurt, and I believe that the load balancer I had created is also here. So let me delete this load balancer as well. And we can also delete the associated target group with that load balancer. Okay, this is good. And we have to perform the same kind of cleanup in other regions. So for me, it was US East 1, where I'm going to go ahead and terminate another EC2 instance. And finally, do the exact same thing in AP Southeast 1. Okay. After this, you should not incur any cost out of these lectures. Okay, so I really hope you liked this section, and I will see you in the next lecture.
Okay, I just wanted to finish all this, yeah, because I don't want to incur any costs. Shutting down Oregon, Ohio, Virginia. Now, most importantly, my California is supposed to be running. Alright, good, this is running. And go back to Ohio. This was a great day. Learned all these records, exactly what I wanted to learn. What these records mean, and I learned more. And I didn't get to the policies. I didn't get through all the policy stuff. I think my notes are ending in health checks. I gotta go to the health check stuff again. Right here.
So let's talk.
Oh, okay, but that's good. Like 5-hour stream. Learned a lot about different records. That's really nice. The cool thing is there's like the routing at the DNS level, which is at the public level, and then there's routing at the load balancer internal level. Really interesting stuff. Alright, I'm going to bed.